This video covers Newton's third law. Newton's third law is, when an interaction takes place between two systems, each system exerts a force on the other, and these two forces are equal in magnitude and opposite in direction. And these two forces are called action-reaction pairs. So you may have heard this before as every action has an equal and opposite reaction. So let's talk about an example so you have a better idea about these action-reaction pairs. In this example, you kick a soccer ball, and when you kick the soccer ball, your foot exerts a force on the ball, and the ball then also exerts a force on your foot. These two forces are equal in magnitude and opposite in direction. Now this may seem a little confusing at the moment, but once we learn more about Newton's laws, we will gain some clarity. So there are two big things that we must remember about action-reaction forces. The first thing is that action-reaction force pairs act on different objects, and just because forces are equal and opposite doesn't mean that they are action-reaction pairs. A great example of this is normal and weight force. If an object isn't accelerating in the y direction, they will be equal and opposite, but they are not action-reaction pairs. So let's do another example. There's a book sitting on a table, and we know that there is a normal force acting on the book and a weight force acting on the book. When we label the action forces, we are going to be filling out this template. So let's first fill it in for the normal force. So we know the normal force is the force exerted on the book by the table, because the table is the reason why that normal force exists. All right? And the weight force is the force exerted on the book by the earth. Alrighty, so take note that our forces on our free body diagram went into the first blank. The object we drew the free body diagram for goes into the second blank, and the other objects that cause the forces go in the last blank. Now let's fill out our reaction forces. We just simply add a capital R to the symbols for the forces to denote that they are reaction forces. And to fill in the rest of the blanks, we just simply flip the two nouns in the remaining last blanks. So for example, the normal reaction force is the force exerted on the table by the book, and the weight reaction force is the force exerted on the earth by the book. We can also draw a free body diagram for these reaction forces. For the reaction forces, we drew the book, which was in the middle blank that we filled in. So for our reaction forces, we are also going to draw the objects located in the middle blank. So we need to draw an earth and a table. So here's the earth, and we know that the weight reaction force is equal in magnitude and opposite in direction. So since weight pointed down, that means the weight reaction must point up. And the normal reaction force, we know that the normal force pointed up, so therefore the normal reaction force is going to point down.